Okay, this is a quick little video on showing you how to use a quadratic formula. The quadratic formula is listed above here, and it is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Remember that the quadratic formula is used to find the x-intercepts or the roots or the zeros of a quadratic function. So the function that we're going to use today to actually find the x-intercepts of is f of x equals x squared plus 3x minus 4. So the first thing we need to do is make sure that our equation is set equal to 0, and in this case it really is set equal to 0. So the equation that I'm going to use is 0 equals x squared plus 3x minus 4. I'm going to identify my a, b, and c that I'm going to use up here in my quadratic formula. So remember, in standard form, ax squared plus bx plus c, this makes my a 1, my b a positive 3, and my c a negative 4. So the first thing that I'm going to do is I'm going to sub into my formula. So my formula here is x equals negative b, so I'm going to put in negative 3 because my b was positive, plus or minus, I'm going to go ahead and square 3, so 3 squared is 9, minus 4 times a is 1, times c is negative 4, and I'm going to divide that whole thing by 2 times 1. So following order of operations, I have negative 3 plus or minus 9, and then multiplying here I have 4 times 1 times 4 is 16, and since I have a double negative, this becomes plus 16 all over 2 times 1 is 2. Simplifying further, I have negative 3 plus or minus the square root of 9 plus 16 is 25 all over 2. I'm going to go ahead and take the square root of 25, so I have negative 3 plus or minus 5 divided by 2. This will then divide up into two equations. Negative 3 plus 5 divided by 2, and negative 3 minus 5 all divided by 2. So my first equation, negative 3 plus 5, is 2 divided by 2 is 1. And my bottom equation, negative 3 minus 5, is negative 8 divided by 2 is negative 4. So my x-intercepts, also called my roots, also called my zeros of my quadratic function, are 1 and negative 4. Remember that when you're solving a quadratic function, whether you're using your graphing calculator, graphing it by hand, factoring, completing the square, or using the quadratic formula, that these solutions that you get, in this case x equals 1 and x equals negative 4, are where the graph crosses the x-axis. So I've already have graphed the function x squared plus 3x minus 4 using my graphing calculator, and I've identified the x-intercepts here. So notice that this x-intercept is x equals 1, and right here is my x-intercept, x equals negative 4. So this graph just verifies that the solutions, or the zeros, to my quadratic function x squared plus 3x minus 4 are indeed x equals 1 and x equals negative 4. Okay, my next example is the function f of x equals 2x squared minus 4x minus 3. So again, I'm going to identify my a, b, and c in this function. So my a is 2, my b is negative 4, and my c is negative 3. So I'm going to again sub into my quadratic formula. In this case, my b is a negative, so when I sub in here negative b, this becomes 4 plus or minus the square root. I'm going to go ahead and square a negative 4, and be careful when you do this. When you square a negative 4, you should end up with a positive 16. So b squared here should always be a positive. Minus 4 times a is 2, times c is negative 3, and I'm going to divide that whole thing by 2 times 2. So again, following order of operations and solving underneath my radical, I have 4 plus or minus the square root of 16, and 4 times 2 here is 8, and 8 times 3 here is 24, and again I have a double negative, so this becomes plus 24, all divided, and I can go ahead and multiply on the bottom here by 4. So solving underneath my radical still, I have 4 plus or minus 16 plus 24 is the square root of 40, all divided by 4. So I'm going to go ahead and simplify the square root of 40 so I get my exact answers. Remember that if you want to just go off to the side here someplace, the square root of 40 breaks down into the square root of 4 and the square root of 10, so it's 2 radical 10. So simplifying this, I end up with 4 plus or minus 2 radical 10 all over 4. Now, because the following simplifies, and if you notice that this 4 right here, this 2, and this 4 are all divisible by 2, then what I can do is I can reduce this function, or this answer here, excuse me, to dividing everything here by 2 that I've circled in yellow, to 2 plus or minus 1 square root of 10 all over 2. So my two answers are 2 plus the square root of 10 divided by 2, or 2 minus the square root of 10 divided by 2. And if I want to go ahead and find the exact answer, or the approximate answers here, I can go ahead and take 2 plus the square root of 10 in my calculator and divide that answer by 2, and you get about 2.58. And if I do the second one, 2 minus the square root of 10, and then take and divide that answer by 2, I get about negative 0.58. So my graph will cross my x-axis at approximately 2.58 and negative 0.58. Alright, our third example here is the function f of x equals 3x squared plus 4x plus 2. And so what we're going to do is we're going to apply the quadratic formula again to solve this problem. And using the quadratic formula, I'm going to identify my a, b, and c again. So in this case, a is 3, b is 4, and c is 2. Subbing into the quadratic formula, this time I end up with negative 4 plus or minus, go ahead and square 4 is 16, minus 4 times a is 3, times c is 2. And I'm going to divide that all by 2 times 3 on the bottom. So, solving underneath my radical, I have negative 4 plus or minus the square root of 16 minus 4 times 3 is 12 times 2 is 24. And because there's only one negative here, this is going to be minus 24 underneath here. All divided by the bottom, 2 times 3 is 6. So, simplifying underneath my radical, I have negative 4 plus or minus the square root of 16 minus 24 is negative 8, all divided by 6. Now remember, when your discriminant, which is the negative 8 right here, is a negative, this means that your solutions are going to be imaginary. So I'm going to go ahead and simplify the square root of negative 8. And negative 8 simplifies down to the square root of negative 4 times the square root of 2. And instead of putting the negative 4 here, I'm going to go ahead and put a negative 1 here. So this will go to 2i radical 2. So in my quadratic formula, it's going to become negative 4 plus or minus 2i square root of 2 all over 6. So again, this particular problem can be simplified because the negative 4, the 2, and the 6 are all divisible by 2. So I'm going to go ahead and I'm going to simplify this to dividing all these yellow circle ones by 2. I'm going to simplify it to negative 2 plus or minus I radical 2 all divided by 3. So my two answers are negative 2 plus I radical 2 divided by 3, and negative 2 minus I radical 2 all divided by 3. Now remember, since our functions here are imaginary solutions, this means that this graph will not cross the x-axis. Alright, the last example is f of x equals 9x squared plus 12x plus 4. So identifying a, b, and c in this function becomes A is 9, B is 12, and C is 4. So subbing into my quadratic formula, I now have negative 12 plus or minus 12 squared is 144 minus 4 times A is 9 times C is 4, all divided by 2 times 9. Solving underneath my radical, I have negative 12 plus or minus the square root of 144. And then I'm going to take 4 times 9 is 36 times 4 here is 144. So underneath here I have 144 minus 144, all divided by 2 times 9 on the bottom is 18. So under here I have 144 minus 144. So underneath my square root symbol I have negative 12 plus or minus the square root of 0, all divided by 18. In this case, your discriminant is 0, which means that there's only going to be one possible answer, because the square root of 0 here is 0. So whether or not you take negative 12 plus 0 or negative 12 minus 0, you're still just going to get negative 12. So I have negative 12 divided by 18, which reduces down, I'm just going to leave it as a fraction, which reduces down to negative 2/3. So this is my x-intercept, or my root, or my 0 of the quadratic function f of x equals 9x squared plus 12x plus 4. Remember that this means that the graph will only cross the x-axis in one place, and that place is at negative 2/3, which means that this right here must be the vertex also, so that the graph will actually be touching the x-axis at the point negative 2/3 comma 0. So the vertex of my function is negative 2/3 comma 0.